Good morning. My name is Sudhakar, lecturer in Government Polytechnic, Coimbatore. So we are discussing about the basic manufacturing technology. In that, we have covered about the lathe machines, right? And yesterday we have started about the broaching machines, right? So before going to start today's session, what we have learned yesterday, right? After the discussion, we will move into this today's session. So, in the last class, we have learned about the broaching. What is broaching, broaches, classification of broaches, methods of broaching. Right? Broaching means it is the metal removal process. Broaching means metal removal process by using the special tool called broach. That is the basic basic answer of the broaching, right? So next the questions arrive to what is that approach? What is the approach? And how much the material removal taking place, right? So for this we have answered that the approach is a multi-point cutting, multi-teeth cutting tool, multi-point or multi-teeth cutting tool is a multi-teeth cutting tool. It is having three types of teeth. One is rough teeth, semi-finished teeth, followed by semi-finished teeth, and followed by finishing teeth. So three types of teeth are on the broach, right? So we can call it as a broach tool. And the next question arises: how much material has been removed by this broach tool from the workpiece? So for this, we have to answer that it is removing 6 mm or less than 6 mm. Can remove 6 mm of material removed or less than 6 mm also possible with this broach. Understood? So, so this is the broach and broaching. Broaching is the removal of metal from the workpiece by using some special type of tool, that is broach. It is having multiple cutting edges, rough teeth, semi-finishing teeth, and finishing teeth. Okay, and in this, the broach operation, how it has been taking place: push and pull. Right, the basic principle of the broach is it is pushed on the workpiece or it may be pulled on the surface of the workpiece. Right, and the broaching is taking place both flat and contour shapes. Both flat and contour shapes, it can be you can be doing that operation. So push and pull type, it can be operated on the machine, on the workpiece, and it may be works on the flat surfaces at the same time contour surfaces. So based on the surface, uh, the broach tools are designed. The broach tools are designed. The basic principle is you can tell that it may be push or pull over the workpiece, over the flat or contour. Okay, and coming to the classification of broaches, we are having so many types of broaches based on the work requirement. The basic broaches are pull broach, push broach, right, and the surface broach, continuous broach, and keyway broach, right, slot broach, based on our requirement, based on our operation. So many types of broaches are there. Okay, so in that we have learned all about all the broaches. And coming to the methods of broaching, in that we have learned about four methods of broaching, right? So one is push broaching, second one is pull broaching, third one is surface broaching, and fourth is continuous broaching, right? In push broaching, it is we are applying the force on the top of the cutting, on top of the broach tool, right? We are applying the force on the top of the broach tool. The broach tool passes through the workpiece. The broach tool passes through the workpiece, right? So in this push broaching, the broach tool is having less number of ticks, right? It is short and it is having less number of ticks. So for this reason, it can remove the material less stock. It can remove the less stock from the material. So that's why we can tell that the production rate is minimum in push broaching. Understood? In push broaching, we are applying force on the top of the broach tool. So the broach tool can pass through the workpiece, and into the broach tool has having number of teeth or less. The broach tool is having number of teeth are less, and the broach tool is very short. So for that reason, it can remove the less amount of material. If it is remove less amount of material, then the production time and production rate is minimum, right? So this is about push broaching. Generally, it is used for internal surfaces operation. The push broaching is used for internal surfaces operation. And coming to the pull broach. In the pull broaching, the force applied at the underneath of the cutting tool, right? In push broaching, we are applying top, and in pull broaching, we are applying the force in the bottom of the broach tool. In this also, the broach tool is passing through the workpiece. The broach tool is passing through the workpiece, right? So if it is passing through the workpiece, so here compared to the push broach, the pull broach is having more number of teeth. Is having more number of teeth. So for this reason, it can remove the material more compared to the push broach. It can remove the material more compared to the push broach, right? So if it is removing more amount of material, the production rate is high. The production rate is high. That means we will do the operations within the less time. By assigning to us, we can uh, remove the material within the less time, right? So this is about the push broaching and pull broaching. And coming to the another broaching operation, that is surface broaching. In surface broaching, and we are again we have to recall one point in both push and pull broach, because the surface broach is differ with this point only. The surface broach is differ with this point only. That's why we have to recall in the push broach and pull broach one point. That is, in push and pull broach, workpiece is stationary, right? The workpiece is stationary and the broach tool is moving. The broach tool is moving. Understood? So that is the main point in the push and pull broach. The workpiece is stationary and broach tool is moving on the surface of the workpiece. The surface may be flat or contour. The surface may be flat or contour, right? And now coming to the surface broach, here the workpiece may be fixed Okay. The workpiece is held in fixture and the cutting tool is held in tool bed, right? Both are fixed positions, right? Both are in fixed positions in surface broaching, right? In surface broaching, what happens in this? Both are cross, both are moving cross each other. Both are moving cross each other. That's why the movement has been taking place in surface broaching. Here, the workpiece is fixed and the cutting tool is also fixed. So these two tool, these two workpiece and cutting tool are across each other while doing the operation. Okay? So this is the main difference when compared to the surface when compared to the push and pull approach. In push and pull approach, workpiece is fixed and the approach tool is moving. In this broach tool and cutting tools, broach tool and workpiece are held in some devices. So while doing the operation, both are moving across each other, right? So this type of operations are done in the internal broachings and round shape operations, right? So it can remove the medium number of material from the workpiece, right? But compared to the push and pull broach, less time you can use it is in less importance. Generally, we are using pull broach and push broach. Okay, and we can also as a reciprocating broaches also, right? And coming to the continuous broaching, in last broaching operation, that is the methods of broaching. In continuous broaching, here, very one point is there is continuous. The name itself tells that it is continuous. That means if we want to do this operation, the workpieces are fixed in circular motion, right? The broach tool is fixed at one point. The broach tool is fixed at one point, and the cutting tool is workpieces are uh, circulating on through that cutting tool. The workpieces are moving through that workpieces and cutting tool. Okay, they are in circular motion, right? To these operations, we have fixed the workpieces in circular motion while passing through the cutting tool. Uh, they are having anti-clockwise circular motion. With that motion, workpieces are moving through the cutting tool. So while moving, the material removal has been taking place. Okay, with that material removal process, after doing the metal removal, the workpieces which have finished their work will go to the another will go to the finished job and they can unload it from the circular motion, right? In the circular motion, these are all moving. These workpieces are all moving, right? So this is about the methods of broaching. All of we have discussed that. These are all methods of broaching. So one is push broach, and another one is pull broach, surface broach, and methods continuous broach. Okay, so these are the topic we have covered in our yesterday's session. So broaching and broaches, classification of broaches, and methods of broaching. Broaching means the removal of material from the workpiece using the special type tool that is called broach. It is having multi-cutting edges, right? And we can call it as a multi-point cutting tool because it is having three cutting teeth, three types of cutting teeth, cutting teeth, uh, semi-finishing teeth, and finishing teeth. Okay, and after that we have learned about the methods of broach. That has been discussed in the yesterday's session. Now we are moving to today's session. Now we are moving to today's session, right? On completion of this period, we would be able to understand the broaching machine. So, classification of broaching machines, constructional details of horizontal broaching machine, vertical broaching machine. Right? Up to yesterday's session. In yesterday's session, we have learned that what is broach operation, right? And broach tool. We have learned about the broach tool and the broaching and types of broaching methods. Now we are moving to the broaching machine where this operation has been done. So that is operated on a broaching machine. In that classification of broaching machine, broaching machines classifications, in that we are having two types of broaching machines. In that we are having horizontal broaching machine and a vertical broaching machine. That will be discussed in today's session. Broaching machines. These are also simplest of all machine tools and they are having less components. So, broaching machine generally consists of work holding fixture, broaching tool, drive mechanism, suitable supporting frame, and these are operated hydraulically and these are using smooth and uniform cutting operation and used for low or high production quantities. Understood? Coaching machines, simplest of all machine tools, and they are consists of less components. So we have discussed about the lathe machine. In that also we have discussed about the components, right? Compared to that lathe machine, broaching machine is having less components. Intentionally, we are not uh, comparing with the lathe machine, but generally, as we have learned the lathe machine, if we are comparing with that lathe machine, we can understood easily. That's why we are comparing. The lathe machine having so many number of components, right? Right, but here in broaching machine, it is having less components, right? It consists of broaching machine consists of work holding fixture, broaching tool, right? Work holding fixture means uh, we have to fix the workpiece in some devices, right? That may be jigs or maybe fixtures. We can fix it on board in this holding devices. Uh, that may be jig or fixture, but here using we are using fixture. Let me tell you what is jig and what is fixture. A jig is a device holding the workpiece and a cutting tool and guide the cutting tool to do the operation. That is called a jig. And coming to the fixture, it is also a work holding device, but it not holding the tool. Just it is the work holding device, right? That the jig function is the fixture function is just it has to holding the work pieces, not guiding the cutting tool. So in this, we are using that work holding fixture. Work holding fixture means in this fixture we have fixed our workpiece, right? And now another thing is broaching tool. We know that already about the broaching tool because broaching tool means the operation, the metal removal process, the metal removal has been taking place with this tool itself, right? So without broaching tool, we are not doing anything on broaching machine. So that is the main important element on the component on the broaching machine, right? So we know about the broaching tool and types of broaching tools and what are the constructional features of broaching tool that has been discussed in our yesterday's session, right? Next, drive mechanism. We know that what is drive mechanism. If the machine has to be operated, some mechanisms have to be included and within the machine itself. So the drive mechanism is used to drive the devices which are going to be manufactured, right? So the drive mechanism may be depends upon the operation, right? So in the earlier session, we have learned that push, pull, and surface continuous broaching. Based on that operations, these drive mechanisms are different. So in push broach, we need only the workpiece is fixed and the cutting tool has to be moved. So that's in that push broach. In that push broach, the workpiece is only stationary and the cutting tool is moving. So in that drive mechanism is only used for driving the cutting tool itself. But whereas in surface broaching, here the cutting tool and workpiece both are held in some devices. So by doing the operation, both are moving across each other. So for this reason, the drive mechanism is the mechanism has to operate both the machine, both the workpiece and the cutting, right? So based on the operation requirement, this drive mechanism depends, right? And suitable supporting frame. This frame is used based on the workpiece, right? Sometimes we need to hold heavy workpieces and sometimes we need small workpieces. So based on the workpiece supporting, we are using some suitable frames. So that's why here also the broaching machine consists of a suitable supporting frame. Understood? So here we have learned that the broaching machine consists of work holding fixture, broaching tool, drive mechanism, suitable supporting frame. The next point tells us that the broaching machines are hydraulically operated. Right? Here we have learned the drive mechanism. So the drive mechanism is to operate some of the devices in the broaching machine. So this drive mechanism is done by the hydraulically, not electrical motors. This drive mechanism is operated with hydraulic devices. That's why most machines are hydraulically operated. Understood? So that is the main point in the broaching machine, and it offers a smooth and uniform cutting edge. Broaching machines are offered smooth and uniform cutting action. So it is the hydraulically operated. Offer smooth means uniform cutting action means removing the less amount of material. That's why where there is no vibrational effects are produced in the broaching machine. The uniform cutting action. So the stock removal is less. That's why we are not getting any deflections of the cutting tool. So the uniform cutting action has been taking place, right? These are all depends upon the amount of stock and operating mechanism. Operating mechanism and amount of stock it will be different, right? And it is used for low or high production quantities. Broaching machines may be used for low production quantities or high production quantities. Low production quantity means the production rate is less, and that depends upon the demand. Low production quantities. If the if some of the things, some of the work pieces and some of the goods we need less numbers, so we can use broaching machines for that reason also. And some of the products are need in less high numbers. So for that also we can use these broaching machines, right? So broaching machines are used for low or high production quantities. Understood? So this is about the broaching machine. So the simplest form of all machine tools, and it is having lesser components. Broaching machines consist of a work holding fixture, broaching tool, drive mechanism, suitable supporting frame. Most machines are hydraulically operated, and these hydraulically operated operate the drive mechanisms, and it can offer smooth and uniform cutting action, and it can be used for low or high production quantities. So this is all about the broaching machines. In the yesterday class, we are discussing about the broaching operations, right? Now we are in today's session, we have moved to the broaching machines, right? In that we have discussing these broaching machines. And after that, we are going to discussing about the classification of broaching machines, right? So based on this classifications, we will discussing some of the broaching machines, right, in today's session. So broaching machines are mainly classified as horizontal broaching machines that may be push or pull type, vertical broaching machines, continuous broaching machines that can be called as rotary table continuous broaching machine, horizontal continuous broaching machine. Understood? So here we have uh, classified broaching machines are two types. One is broaching machines are push or pull type, that may be horizontal broaching machine and vertical broaching machine. So we know that push or pull type that has been discussed in the study session, and today also in the first half we have learned that push or pull type. We know already very well in that push or pull type the workpiece is fixed and the cutting tool is moving on that workpiece, right? Right. So this is horizontal broaching machines, and according to that, another type of broaching machine is vertical broaching machine. Another type of broaching machine is vertical broaching machines. And vertical broaching machines also in that the workpiece is fixed and the cutting tool is moving. And coming to the continuous broaching machine, we know that the continuous broaching machine, we have observed that in that products workpieces are fixed in a circular path. They are moving around the circular path. While moving in the circular path, the cutting tool is fixed at one position. The broach tool is fixed at one position. By doing this, by passing through this uh, cutting tool, the material removal has been taking place. So here the production rate is high because we are continuously doing the operation, right? So in that we are having two types: rotary table continuous broaching machine, horizontal continuous broaching machine. In rotary table continuous broaching means we have observed in the study session that the cutting tools have been moved in a circular path, right? So they are moving in circular path. Whereas in horizontal continuous broaching machine, that means we are sending the work pieces in one line. So after passing through this cutting tool, the material removal has been taking place, and after that passing, we are removing the workpiece within that line. So by this, we can tell that it is a horizontal continuous broaching machine. Understood? So basically, horizontal broaching machines, they have been push or pull type, and vertical broaching machines, right? And continuous broaching machine. In that continuous broaching machine, rotary table continuous broaching machine and horizontal continuous broaching. Now we we are moving to discussing in detail about the horizontal broaching machines and vertical broaching machines, right? So classification of broaching machines, in that we are now moving to the horizontal broaching machine. That is horizontal broaching machine may be push or pull type, right? So in the diagram we have observed that horizontal broaching machine. So what are the components it is having have to be observed, right? So base, it is the base to all the components of the machine, and here housing, in that housing various mechanisms, driving mechanisms and other mechanisms are included in that housing. Okay, on the top surfaces there is having a pulling head. The pulling head is used to operate the uh, cutting tool, broaching tool. Right here, the teeth, with that the teeth, the broach tool is appears like this. So here work fixture means in this area we have fixed that work piece, right? So here the arrow shows that it is operating like in this direction. So we can tell that it is a full broach. We can tell that in this direction. We can tell that it is a full broach. Why we can call it as a, because applying force is here. So this applying force is here. The tool is traveled like this. The tool is traveled like this. The broach tool is traveled. That's why it is a full broach. Okay. So here the work picture is there. Here it is removing the material, right? So this is the driving mechanism, and it is hydraulical operated machine. Horizontal broaching machines. Main parts of the broaching machine are, we have observed already that bed, housing, drive mechanism, broach, pilot, picture, right? So these are the points we have covered in that broaching machine: bed, housing, drive mechanism, broach, pilot, and picture. Okay. With this, we have to learn the detail of each of the product, each of the component. There is bed. So where is the bed situated in the diagram? We have observed it is at the bottom part of the most bottommost part, and all other elements are supported on this bed. We can easily tell that bottommost part, bed is the bottommost part, and all other parts are rests on this bed, and it supports other parts of the machine. In any machining, slate machine, maybe lathe machine, horizontal machine, and coming of the uh, uh, but another types of machines, all other machines having bottoms, another beds. So on that beds, all other elements are supported, right? And most of the materials, most of the beds are made of cast iron. Okay, you can simply tell that the bed is the bottommost part of the machine, and it supports all other parts of the machine, and it is made of cast iron. It is made of cast iron. Housing, and another part is that housing. I have already told you in that housing, the drive mechanism is houses, and houses the pulling head. It houses the pulling head. Pulling head also is there within the housing. Drive mechanism is there, and pulling head is there. Drive mechanism. What is the function of drive mechanism? Drive mechanism drives the full head. Right? The drive mechanism drives the full cutting stroke speed is less. Here the cutting stroke speed is less. I have already told you within the diagram it is a pull type approach because the applying force is in this pulling direction. That's why driving mechanism drives the pulling head and the cutting stroke speed is less, right, while doing the operation because there is a contact between the workpiece and the cutting tool. So within that contact, there may be vibrational effects are produced. With that vibration effect, the cutting tool may be damaged and the workpiece may be damaged. The cutting tool here is the broach tool. For this reason, we are maintaining the cutting stroke speed is less and the return stroke speed is more to reduce the manufacturing time, because why we are providing return stroke speed is more means it is an ideal stroke. Ideal stroke means there is no cutting process has been taking place while doing the machining operation. That's why we have to do that. We have to arrange that return stroke should be more. Cutting stroke speed is less and return stroke speed is more. So with that, we are reducing the we are reducing the speed. Sorry, we are reducing the manufacturing time. While that reducing, we are increasing the productivity. That's why some mechanisms are there, quick work rate mechanisms. That will be discussed in our next subject, that is planing and shaping machines. In that we have discussed clearly about the quick return mechanisms, right? So here the point has to be noted that the cutting stroke should speed is less to reduce the vibrational effect and also damage of the cutting tool and workpiece, and also reduce the heat produced between the cutting tool and the workpiece. Because of the heat produced, the properties may be changed. The workpiece properties may be changed. So that's why we are maintaining the less speed while doing the cutting operation. And for the ideal stroke, we are maintaining the speed is more. And here the broach pilot is there. It holds the broach rigidly. So the broach pilot is holding the broach tool rigidly. So while doing the operation, the broach tool may not loosen and it while because of this rigidly hold, it may be traveled in a good path and fixed path, uniform path. Sorry, it is fixed on the uniform path. That's why we have to fix this broach pilot in rigid manner. So with this rigidity, it does not loosen and it travels on the workpiece on the uniform cutting path, right? So this is the driving mechanism, and also in the picture holds the workpiece rigidly. Already we told that the picture is the work holding devices. In this picture, we have pictured the work, right? So this is about the driving mechanism, housing, and bed. So these are the components of horizontal broaching machine. And some of the features of horizontal broaching machine. In this, we can do the both the surface and internal operations. Internal broaching can be done, right? By doing the horizontal broaching machine, uh, surface and internal broaching, both operations can be done. And the broach is securely held in a pulling head. The broach tool is securely held in a pulling head. I have already told you that while doing the contact between the workpiece and cutting tool, there is no need to loosening the cutting tool. That's why it can be securely held in a pulling head, right? So with this, we can do the internal and surface broaching operations. We know that the surface broaching operations, right? In surface broaching, broach is pulled over the surface, right? Surface means we have to do the remove the material from the surface, right? So for doing this operation, the broach tool is pulled over the surface of the workpiece, right? And for internal broaching, broach is pulled through the one. For internal broaching, in the diagram we have observed in push broaching operation and pull broaching operation. So for doing that operation, that is called, we can call it as the internal broaching. For internal broaching, the broach is pulled through the work, right? So for surface broaching, the push work, the cutting tool is pulled over the surface. For internal broaching, the cutting tool is pulled through the workpiece, right? So these are the operational features on the horizontal broaching machine. So as compared to surface and internal broaching machine, the horizontal broaching machine mainly used for the internal broaching operation, right? And it's operated at a cutting speed of 3 to 5 minutes per minute. The cutting speed is 3 to 5 meters per minute. So the horizontal broaching machine is used for surface and internal broaching. Surface means it is pulled over the surface, and internal broaching means it is pulled through the workpiece, and it is mainly used for internal broaching operation. And it's operated at cutting speed of 3 to 5 meters per minute, right? And speed of return stroke. So observe this speed of cutting speed is 3 to 5 meters per minute, and whereas speed of return stroke is 30 meters per minute. So we can tell that we are already discussing this point. The return stroke should be high, right? Because it is a ideal stroke. Ideal stroke means it is not operating any. It is not doing any operation, any manufacturing or any material removal. That's why we are providing high speed. Right. Next, hydraulic drive is used for pulling head. So to do this, we have to pulling the broach tool. So to do that, here we need hydraulic drive. So that hydraulic drive is used for pulling it. And it is operated at infinitely variable range of cutting speeds. Horizontal broaching machine operated at infinitely variable range of cutting speeds. Hydraulic cylinder is housed on the right side of the machine. In this mechanisms, hydraulic cylinder is housed on the right side of the machine. And long broaches are easily handled in horizontal broaching machine. Heavy workpieces are easily handled, occupies more space than vertical machine. So horizontal broaching machine occupies more than space than vertical machine, but it can heavy workpieces it can be handled easily, and the long broaches are also easily handled. Right? It is used to machine keyways, lines, slots, round holes, other internal shapes. These are further classified as the surface broaching machines, internal broaching machines, right? So, based on the operations, so keyways, splines, slots, round holes, right? Keyways, splines, slots means there are surface broaching machines. These are operations are done on the surface broaching machines. The round holes, this is operated on internal broaching machines, right? So based on that requirement of operation, the horizontal broaching machines are furtherly classified as surface broaching machine and internal broaching machine. So, right. So that is all about the horizontal broaching machine. Now we are moving to the vertical broaching machine. In this vertical broaching machine, observe here it is a column. Right. The broach is fixed in a vertical position, and here uh, the workpiece is held in a picture. Right. Here the direction is showing the movement of the cutting. The direction is showing the movement of the cutting. And here the slide is there. So it is also like a pull type. So we are applying force. The drive mechanism uh, is in this area. So that's why the cutting tool is moving, the broach tool is moving in this direction. So we are applying the force in this direction. That's why the cutting stroke has been taking place in this direction. So it is also a pull type of broaching machine, right? So some of the pull type or some of the vertical broaching machines I have observed in this diagram, right? So the cutting edges, we know that. So it is removing the material in the form of small amount of chips. So this is a vertical broaching machine. It may be either push type or pull type. full type is popular, right? We are observing in the diagram, it is a full type. So that's why we are discussing about that. And the main parts of vertical broaching machine are base, column, ramp, and approach, picture, and table alignment. So all of the points we have covered in the horizontal broaching machine. And base, we know that already it is a base point, bottommost of the part that supports all other elements. So all other elements are situated on this base that will be discussed in the horizontal approaching machine. So all other points have been discussed, and the RAM, here the RAM, because it is a vertical type, so RAM is the another element. So with that element it can be moved, the rectangle is moved. In the vertical broaching machine we are getting three models, that is pull up, pull down, push down. Pull up model is most popular. This pull up model is most popular, and the broach is securely held in RAM. Right? Occupies less floor space. Occupies less floor space. So vertical machines are broaching machines are available in three models. Are available in vertical type. Pull type, pull up, pull down, push down. Pull up model is most popular, and the broach is securely held in RAM. Right, broach is securely held in RAM, and it can occupy less floor space as compared to the horizontal broach. Right. So with this, I am concluded today's session. Right. So because today's session has concluded. Today we have learned the horizontal broaching machine clearly, and just we are touching the vertical broaching machine. In tomorrow's session, we are starting with the vertical broaching machine and finishing the vertical broaching machine. And after that, one type of broaching machine is there, right? Vertical broaching, duplex broaching machine, and we will finish these two broaching machines and go into the another part, right? So today I am concluded, and the session is closed now. I am closing this session. Thank you.